All right, we're moving right along. This time we are going to be looking at writing an equation for the nth term of a geometric sequence. Again, this is chapter section 10-3. We're now at example 2. And unlike the previous example, I don't see any problems here in the textbook, so we're going to work directly from the guided practice there on example 2, which is located on page 675 in your textbook. So once again, we are dealing with the nth term of a geometric sequence, and so there's our basic formula for a geometric sequence. AN equals A1 times the common ratio R raised to the power of n minus 1. Now, we're going to be given some information, and we're going to be asked to write the equation for a specific geometric sequence. And in this example, we're given just a teeny bit of data. We're actually given a geometric sequence, which I think continues on. I should have dot, dot, dot out here. It would be helpful if I put them in order. Why don't I do that? That's pitiful. Sometimes it's hard to write on this screen. All right, dot, 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 with my hand up in the air. So, what have I got to find? Well, I know what A1 is. That's negative 0.25. But what I don't know is I don't know the common ratio. But I got enough information here to figure it out. And you may remember from chapter section 10.1, the way I find the common ratio is I take the second number of the sequence, 2, and I'm going to divide it by negative 0.25. And that comes to negative 8. And I might want to do that again just to satisfy myself that I do have the common ratio. And I could divide negative 16 by 2, which is also going to be negative 8. Or I could just multiply 2 times negative 8, and that's going to equal negative 16. And so I'm pretty well satisfied that for this, that R is equal to negative 8. Okay, so I want to write this equation. Well, I don't know what n is. I've not been given that, but that's not a problem because I'm trying to write an equation for the entire geometric sequence. And this is going to be an easy one. So I got an equals, we'll put this in parentheses, negative 0.25 times negative 8, close my parentheses, negative 8, n minus 1. And shazam, that is the equation for the geometric sequence that contains the numbers negative 0.25 to negative 16 and 32. Shall we do another? Well, it doesn't really matter if you want to or not. We're going to. Okay, mathematicians. We're still here going to be writing an equation for the nth term. We got our basic nth term formula for a geometric sequence. AN equals A1 R raised to the power of n minus 1. And let's see what data we've been given. Well, we've been given A3 is equal to 16. And we've been given the common ratio 4. But in order to write the equation for the nth term, there's something I've got to figure out first. And I need to know what A1 is. But I've got enough information here to find A1. And once I find A1, then I can write an equation for an arithmetic sequence that would have the third number of that sequence equal 16 with the common ratio to be 4. So let's start out here. So I'm going to write it like this to begin with. I got A3, which is what I know, times A1 times R raised to 3n. How do I know it's 3? Because I got the third number of the sequence here, A3. 3 minus 1, it's going to be 2. Now let's plug in some numbers to this thing. Well, A3 is equal to 16. And A1 is what I'm solving for initially. I know that R is 4, and it's going to be squared. 3 minus 1 is 2. So I got 16 equals A1 4 times 4. 4 squared is 16 times 16. And so I'm going to divide both sides of this equation by 16. And so A1 is going to equal 1. All right, well, now I'm ready to write this equation. And I'm going to just simply say AN is equal to 1. That's A1. And let's see, I'm going to put that in parentheses. Times 4, the common ratio of this sequence, N minus 1. How about it? Go do it. Go forth and conquer.